Well, good evening. Welcome to Space Oddities on this Monday evening. I hope everybody's okay out there. Thank you for being here. And if it's your first time here, you are especially welcome. We are Space Oddities. Tonight we are, for me, and Roger and Michael and Lou and Rachel and Jonathan. How are you guys?
Very well, thank you.
Okay,
Brilliant.
good, thank you.
Good. Ready for another evening on fun and frolics in the world of astronomy? Yeah, fantastic. I hope everybody's had a good week. So for the next, I don't know how long we're going to go for tonight, at least an hour. Sit back, relax, and we're going to tell you lots of wonderful things. We got quite a packed program tonight. We have the results of our competition to win a telescope. That'll be coming up later in the program. One lucky child is going to win a telescope. And we'd like to say thank you so much for all your entries. It's been so difficult to decide, as always. The results of the competition we'll be announcing later. We've also got Lou, who's going to be telling us another story of bad astronomy, where astronomers got something wrong. We've got Moon of the Week, which this week is Saturn's moon Enceladus. And what else have we got coming up? Lots of lovely stuff. Usual features. We've got Jonathan is going to give us the NEOWatch update, I hope. And Daz is going to be talking about a few things, and Michael as well. Daz seems to have disappeared already, so we're hoping he can find his way back, and I'm sure he will be with us. Oh, there he is. He's trying to get in now, so let's just let him back in. Hi, Daz. Welcome back.
Oh, is anybody there? Hello.
Okay, so as always, it's been a busy week in the world of astronomy and space flight. So we'll crack straight on. We'd like to thank our sponsors, Rother Valley Optics, for supporting us in this little venture of ours. And we'd also like to thank all of you who bought us coffees last week. As always, your coffees go into our coffers, so we can do more.
You can stay up at night and look at the stars, right?
Yeah, keep us up at night. Absolutely true. Absolutely true. Speaking of what we are doing, we were chatting last week about doing some merchandise for this summer, specifically T-shirts. And some of us have come up with some designs for T-shirts. And we thought we would let you, the viewers, choose the design for the T-shirt for this summer, the Space Oddities T-shirt, as you're going to be the ones wearing them. So we'll run a little poll later to see which designs you like, or which ones you don't, or none of them. So if you don't like any of them, that's fine too. And we'll go back to the drawing board, scratching our heads. So we hope you like what we've had a chance to. We must point out, of course, that none of us are professional designers or artists or anything like that. So it's just what we've come up with, and we'll put that to the vote a little later. Which T-shirts you will be proudly sporting this summer if you want to buy one. So there we are. Okay, well, let's crack straight on. And as always, I'm going to hand you over to a man who needs no introduction.
Oh, okay.
So he's not going to get one.
Okay, here we go then. Eyes down for the next 7 days from the 15th to the 21st of May. Good grief, where's it all going? Anyway, so we have a new moon for Friday evening at 6 minutes to 5 in the evening, if you want to be that precise about when the new moon is actually happening. But towards the end of the week, we've got a new moon, so that may be advantageous if the skies are clear for your galaxy imaging or whatever you're into. But here's the planet Venus that I took a few nights ago. And,
lovely, Roger.
I was trying out one of my new telescopes. So
well, it works.
Yes, it's getting there, but I need to put a UV filter and an infrared filter on, and then we might get some cloud details. But one thing at a time.
Yep.
So
Very
when
nice,
I've been
Roger.
doing that at night, I'm been doing this in the daytime. Some solar imaging in HA.
Wow.
So watch out, Kevin Earp. Here I come.
Very good.
Mm,
Excellent. That.
yeah. So it's work in progress. This was from earlier on today. So third attempt at playing with the settings on my Quark. So I'll see the doctor about that.
Yeah, I would. You can get some money.
So this is basically what the setup is, although I have got an eyepiece in there at the moment. And that's a Skywatcher Heliofind, which you put, set up, switch on, and just have it pointing just to the left of the sun. And then it picks up a GPS to find the sun for you. Just adjust it, and it'll follow around for the rest of the day. How clever is that? So I'll be able to do lots of little time lapses of prominences and other events on and around the surface of the sun. So
So they've actually got GPS satellites orbiting the sun now, have they? That's clever.
Well, something like that, allegedly. So yeah, there's the Quark. You can see there's a little green light between the little tuning knob and the cable to provide the power to get that echelon up to temperature to see that very fine detail in hydrogen alpha.
Wow. High-tech stuff.
I know. So here we are for the night sky for the week. Unfortunately, there's not too much planetary activity, only a bright Venus and a very tiny fading Mars now over towards the western horizon. But we have got the summer triangle starting to appear now with Vega, Deneb, and whatever to lighten our mood with some interesting objects through the Milky Way. And obviously the Milky Way core will be appearing earlier and earlier through the night as the months and weeks progress. So there we go. Okay, so when we've reached that, on Thursday, during the daytime, I've just switched off the atmosphere so you can actually see the positions of Jupiter and a 5% moon, and it's going to be a very close graze on the Thursday afternoon. The higher in latitude you are, the better chance you've got to get a total occultation. But where I am down in the southern parts of the UK, it's going to be a near graze. But it is an opportunity. But obviously you'll have to have a good setup with a telescope to see this, because the moon being only 5%, you're not going to get much chance of finding that, or even Jupiter during the daytime. But about 3 o'clock in the afternoon will be its closest approach in the daytime sky. So if there is an opportunity, see if you can find it. Absolutely. Good luck with that.
Yeah.
But concluding my little presentation, we have a James Webb interesting image from the star Fomalhaut, where we've got this matter, and we got star with some debris going around, with star forming with some planets coming around into the around it. But the scale of this is quite huge. As you can see down in the bottom left, you've got a little marker there, and that's 80 astronomical units. So the disk is quite spread out from the actual star. So it'll be interesting to see what size these planets will eventually be, and whether they might eventually move in towards the host star at some future point.
That's amazing. The size of that, you just can't comprehend it, can you?
No.
And it's worth pointing out as well that the black spot in the middle is not a black hole. That's simply where there's no data, missing data. So
not a spoiler alert.
No, absolutely.
It was a speck of food.
Yeah, so
that is amazing. Of course, Fomalhaut has been imaged many times before, but they've never caught that inner disk of dust before. It took the James Webb to bring that out.
Yeah.
So
yes.
yeah, that's from
It's
the
not
MIRI
an-
instrument.
It's not an occulting disc then.
No, no, that'd be really weirdly shaped if it were.
Yeah. It's like the Death Star explosion.
Yeah, that's right. That's right. Absolutely amazing. So we're looking at a solar system in the process of formation. That's
That's wonderful. That is
amazing, isn't it?
Yeah.
Anybody know the age of Fomalhaut? No.
It's
Just
Obviously a
on there a
young
minute
star,
ago.
but
I think it's good that it's a well-known star as well.
yeah, absolutely.
You know,
Yeah. Was it? It's only 25 light years away, isn't it? Something like that.
yeah, yeah.
Yeah. Fantastic. Right. Well, thank you for that, Roger. That's absolutely
Okay, no problem.
absolutely brilliant. So, so there we are. You may remember, viewers, that last week we were chatting about space stations of the future. Well, such is the pace at which things are developing in space flight, and particularly commercial space flight, that we have some more news of another space station project, don't we, Daz?
Yes, we certainly do. And this one, I think, is quite an exciting venture, because not only is it a company called VAST, which will be launching this space station, which they will call Haven 1. They've also booked their first mission to this space station. And what it is they've actually teamed up with SpaceX, and the actual space station will be launched on Falcon 9. And it will be no earlier than August 2025. Now, it being SpaceX, and they've already booked their first flight up there, looks really exciting. Looks like something that can actually happen within the time scale that they're talking about. But I'll just read you a little bit. VAST, a pioneer in space habitation technologies, announced today their plans to launch the world's first commercial space station called Haven 1, scheduled to launch on SpaceX Falcon 9 rocket to low Earth orbit no earlier than August 25th. And also in future missions, it will be using the Dragon crew module.
Yeah.
For taking its crews up there. So this is actually, like I said, a definite joint venture. So it's something to look forward to. They're actually, I was just reading about it. VAST is selling up to 4 crewed seats on the inaugural mission to Haven 1. Expected customers include domestic and international space agencies and private individuals involved in science and philanthropic projects. So, this is going to be open to everybody. It's not just going to be a closed shop. They are looking at the longer term to actually build a much larger space station. And up to, I think it's somewhere, I read somewhere, it's about 100 meters long that they're looking for eventually. But this is an exciting, and also, as I mentioned last week, again, one of the newcomers, I mentioned the aerospace Loop space station, which is going to use artificial gravity. Well, so is this as well. This Haven 1 will again be using, will be able to generate artificial gravity, and again, I presume it's using a gyroscope type system to actually produce artificial gravity. So things are moving ahead, and it seems to be space stations with artificial gravity is the way to go. But this originally will be quite a small space station, but it looks, like I said, it's a joint venture. This is the first space station company who have actually booked all their flights ready for her. And so hopefully by 2025, August 2025, we'll have a new space station up in the sky.
Yeah.
Yes, absolutely fantastic.
I think that's a brilliant space station to have in the next couple of years, especially the announcement being made on the 50th anniversary of the launch of Skylab. It does look like, what Skylab, perhaps what Skylab should have been. And I believe what they're going to do is they're going to use multiple Haven 1 type modules strung together to make the larger stations, I understand. So that's going to be an interesting one to follow.
Absolutely. So exciting times yet again in space. Never stands still. We make an announcement one week and then next week there's another update. And I've actually got an update about a black hole story that I talked about a couple of weeks ago that's coming up a little later, and that's quite amazing as well. So there we are. Okay, well, I think what we'll do now is we will go over to the lovely Rachael. And Rachael has been, as always, patiently collating your gallery entries, and we thank everybody who contributes to the gallery. If you would like us to feature your astronomical images, then just put them in an email, 1 image per email, please. Entitle the email gallery entry and send it to spaceodditieslive@gmail.com, and we will feature it. No problems at all. So I see we've had some of the usual suspects sending in images this week, Rachael. So thanks to everybody who has, and let's see what's in true Vision on style. What have we got in the gallery this week?
Yeah, it's a nice and small gallery this week, and it's good because we've got a lot to fit in the show, so it works out well. And I probably shouldn't introduce the first one because Roger Hyman with the extra R's might want to talk about his own image. So if you're there, Roger, take it away.
Well, I just got a quark a few days ago, so I thought I'd go and give it a good old airing. So these are one of the few first images that I've managed to produce, and as it says in there, this is a combination of one of the surface and one of the prominences done from the same exposure, but 2 different alterations in different layers, so you can see one and the other at the same time. Otherwise the prominences wouldn't have been visible at all, but not too bad. I'm getting there, but still a little way to go to get to Mr. Earp's level.
Yeah, no, it's a really nice image, Roger. Well done. Lots of texture.
Yes.
Then we've got an image by Jerry. He's called this the Cosmic Question Mark Nebula in Cepheus. He says he's unable to capture the whole nebula, but a wider crop would reveal the shape with a nebulous dot below, which I guess would make the question mark in the title. And here we go. Which again, I always call this the whale tail nebula because I think that black structure sort of in the middle looks like it's a whale tail splashing out of the water.
Yeah.
I don't know if you can see it. There we go. So thank you, Jerry. And I think we're finishing with another one by Jerry, which is Macarian's chain in the Virgo cluster, which I believe it's a string of around 8 galaxies, I think.
Very nice.
That's
which
all right.
is really nice. So that stretches between Virgo and Commodore and, well, Berenices. So really nice. We've not managed to do this one yet ourselves. I really would like to have a go though. So I keep getting inspired every week. I see new things and I want to go and do it. But the sky is rubbish and there's no dark. So I think I will have to wait.
Yeah, that's lovely. That's beautiful.
And that is our short and sweet gallery. I will stop it there.
Ooh.
Okay. Well, as I said, don't forget, if you would like to see your astronomical images featured in our gallery, then put them in an email, entitled the email gallery entry, 1 image per email, please, and send it to spaceodditieslive@gmail.com. And we always love looking at your images, and we are very grateful for your support in that. And as we say quite often, the standard is always very high, and sometimes they're indistinguishable from professional images with large telescopes. So such is the skill that you have out there. We know you have. So send your images in. We'd also be interested in not just astronomical images per se, but any sort of skyscape images or anything like that. Because I've been noticing the last couple of weeks how brilliantly bright Venus has been in the evening sky, and so anything like that with astronomical objects in, we'd love to see as well. So thank you, Rachael, as always, for your collation of all of those, putting that presentation together, and there we are. So let's move on now, and what we're going to do, I've got a bit of black hole news to impart to you, and then from there we're going to go straight into a moon of the week because it's like that. So firstly, just give me 1 second, and I will just update you on a story that we carried just a couple of weeks ago. You may remember this image here. Hang on 1 second. This image was purported to be, and 1 second, it's running away with me. This image was thought to be a runaway black hole, a supermassive black hole that had been ejected from a galactic collision where there were 3 galaxies involved. And this supermassive black hole is meant to be roaming through space, and it compresses the gas in front of it, trails it behind, and the compressed gas collapses to form stars. So this is actually meant to be a trail of stars behind this supermassive black hole. Now, first of all, the size of this is immense. That trail of stars is twice the length of our galaxy, the Milky Way. So it's absolutely inconceivably immense. But when astronomers took a closer look at it, mainly because they weren't quite convinced that it was what they thought it was because of the size, they realized that it's not, in fact, what they thought it was. Have a look at this. This is a similar feature. It's an inverted image, so black on white. And it looks very similar to that structure. But in fact, it isn't. What you're looking at in this image is a galaxy which is edge on to us. This is known as a thin spiral galaxy because it doesn't have a bulge in the middle. Quite why these spiral galaxies don't have a bulge in the middle is a story for another day. But when they looked at the previous image, this one, they looked at the light coming from individual stars they could make out to see what the so-called radial dispersal is. That is to say, which stars are moving away from us and which stars are coming towards us. And what they realized is that, in fact, what we are looking at here is not a black hole trailing stars behind it. It is, in fact, one of these edge-on spiral galaxies that doesn't have a bulge in the middle. At least they think that's what it is. So unfortunately, although theory predicts that these runaway black holes, having been kicked out of their galaxies or the galactic collision, theoretically this is exactly what they should do, compress gas in front of them, which then trails behind to form stars. But they believe that what we're looking at in this image is in fact a spiral galaxy edge onto us. So, but they're still looking for these runaway supermassive black holes because the physics says that they should exist. So you can stand down on the black hole alert there, but obviously more work to do on this. But they're pretty sure this is a galaxy that we're looking at and not a runaway black hole.
If it is a galaxy and we're viewing it edge on, then it's rotating. Everything rotates in space. So you should see a different Doppler effect on one edge than the other if we have the spatial resolution to do that.
That's right. That's right. And this is, I don't know about the edges, but this is why they believe it's a galaxy, because some stars are moving towards us in that inverted commas trail, and some are moving away from us. So this is why they came to the conclusion that it is in fact a galaxy. but it's really, really edge on, isn't it? I mean, it's incredibly thin. So so there we are. Anyway, that's another good black hole story down the drain, but we'll keep you updated on that if there are any developments. So there we are. Okay, well, let's move on now to our new feature, Moon of the Week. And this week it's Saturn's moon, Enceladus, which has become the focus of much attention in recent years because of the discoveries made by NASA's Cassini probe. And we're going to just have a look at this moon. So first of all, just some basic facts about Enceladus. It's the 6th largest moon of Saturn. It orbits between Tethys and Dione. You can see there. That's where it is in relation to the other moons. So it's one of the inner moons of Saturn. It's got a diameter of more or less 500 kilometers. It's not quite spherical, so that the pole-to-pole diameter and the equatorial diameter do actually vary, although not by much, but it's not an exact sphere. It's got a surface temperature of minus 198 degrees Celsius, which makes it incredibly cold, obviously. And it was discovered in 1789 by William Herschel. It has a very high albedo of 0.81. The albedo is the amount of light that is reflected off it by the sun. So it is incredibly bright, and until the space age, it was never really clear why this moon was so incredibly bright, because it reflects nearly all of the sun's light. It orbits actually in one of Saturn's rings, the densest and the most diffuse part of Saturn's E ring. And you can see the E ring there. The rings of Saturn are given letters, and that's the E ring. And it was imaged first close up by Voyagers 1 and 2. This is a Voyager 2 image of Enceladus. Now, after the Voyagers, scientists were left with two questions, really. The first thing that you see when you look at Enceladus, you'll notice that it has a varied terrain with some cratered areas, but the rest of it is very, very smooth. And the fact that it's very smooth indicates that it's a very young landscape. So the question they asked, well, why are there these two types of terrain? Why is there a cratered area and a perfectly smooth area? How did that happen? And also, they were intrigued by the fact that Enceladus does orbit within the densest and the most diffuse part of the E-ring. And these were questions that astronomers really wanted to know the answers to. And it had to await the arrival at Saturn of the famous and much missed Cassini probe, because Cassini discovered that, in fact, Enceladus is venting large amounts of water and water vapor and ice from an area near the south pole of the moon. And this is a false color image, but you can see there that there's a lot of activity going on there. And these plumes, Cassini discovered, were found to originate from fissures in the South Polar region, which were nicknamed tiger stripes. And there you can see emissions coming from those tiger stripes towards the South Pole of Enceladus. And that's where they are in the yellow box. Those are the tiger stripes, sort of parallel fissures towards the South Pole. And this was a complete revelation that nobody really expected to see this activity on this moon. Here's a close-up of those tiger stripes, and you're going to there's actually one closer, and this is a Cassini image, and this is, I think, really dramatic image of one of those tiger stripes. And obviously, this is something that was not well understood. Here's a lovely image of a backlit Enceladus, where you can see quite clearly that or those plumes of material emanating from the tiger stripes. And here's a close-up that Cassini did. And, that material is very bright. indicating a lot of ice in it that's reflecting sunlight incredibly. And this, of course, explains the albedo of Enceladus, because some of that material falls back onto the surface to coat the whole moon in ice. But some other quantity of that ejected material escapes into space, where it actually forms the E-ring. So what Cassini discovered was that the whole of the E-ring consists of material that has been ejected from this little moon Enceladus. And there's a lovely image showing that quite clearly, with Enceladus in the middle and that arc of material in the E-ring. So this was the first time that a moon near Saturn certainly has ever been seen to act in this way. It's a really, really active moon. And here's an artist's impression of what it might look like if you were actually there. I think that's a lovely painting, and it really does give the impression of that incredible activity going on at the surface. Here's a time lapse of Enceladus when Cassini was approaching it, and you can't miss what's happening there. And here's another one receding from Enceladus, with those plumes really brightly illuminated, reflecting a lot of light. So here's what astronomers think is happening. As Enceladus has an icy crust, which isn't shown to scale here, but it's thought to be about 5 kilometers thick. And beneath that ice, there is thought to be a global ocean. So Enceladus is in fact a water world, as are many other, or several other moons in the solar system. Beneath the global ocean, and nobody knows how deep that global ocean is, but Enceladus is thought to have a rocky core. And that material from the ocean is spurting out of the tiger stripes towards the South Pole. Now, the exact mechanism for that is shown here, that you have tidal heating coming from below, and the water rises through cracks and becomes partially melted below the surface, below the crust, and eventually expands and it vents to the surface, and the melted ice drains back into the ocean from those sort of reservoirs. Now, what happened with Cassini is that the mission managers and the engineers came up with an amazing adaptation of Cassini to enable it to fly through one of those plumes to actually analyze what was in the plumes. And it did this a few times. The first time was on March the 12th, 2008. Cassini dipped low to fly right through one of those plumes and sampled it and analyzed what was in the plumes. And there were lots of surprises in the plumes, because in the plumes there was a lot of water, which is being ejected at about 300 kilograms per second from the tiger stripes. There was crystalline ice. Ice on the Earth doesn't form these types of crystals that we find on Enceladus. There's methane, there's oxygen and nitrogen bearing organics, carbon dioxide, molecular hydrogen. So this is a real sort of potpourri of chemicals that are being ejected from the tiger stripes. And there are also rock fragments in which they found silicon dioxide. But some of those elements, if you like, some of those chemicals had been in contact with rock. So they definitely had come up through a liquid environment and ejected into space. And this is, another good reason for believing that there is a global moon beneath that icy crust of Enceladus. And here it is in a little more detail. Astronomers believe, or planetary scientists believe, that on the ocean floor there might be things that are analogous to the black smokers along the mid-Atlantic ridge on Earth, this geothermal activity. I'm sure you've all seen videos of the black smokers. And on Enceladus, because of the ice, of course, they will be white smokers. And there you have, as I was talking about, water-rock reactions, which they found in the plume, the particles they found in the plume, the hydrothermal vents leading to the surface jets. So just to summarize all that, Enceladus is an active world with its interior heated by Saturn's gravity, so-called tidal heating. It actually has the purest water ice surface of any body in the solar system, and of course that's constantly being replenished, which explains why the surface is so young and why there are so few craters, because the surface is constantly being resurfaced, if you like, with all of that material falling from the plumes. It has a global underground ocean, and the chemicals and the water vapor and the ice and everything else and the gas actually creates Saturn's E-ring as Enceladus moves round in its orbit around Saturn. And its ocean floor may be home to geothermal features like the black smokers along the mid-Atlantic ridge on Earth. And of course, all of this makes Enceladus a prime candidate for the possible existence of life on this little moon orbiting Saturn. So there you are. That's the moon of the week, Enceladus. And there we are. Does anybody want to say anything about that?
Andy, can I say something quickly?
Yeah.
Just a recent news item to say that there's a lot more moons being found orbiting Saturn, and total number now has gone up to 145.
145. Good.
Yeah.
Will it ever stop?
Exactly.
Well, when we were doing the amazing astronomical alphabet on the radio, we were doing moons and all that, and every 5 minutes there's a group of lads in Hawaii, and they just spend all their time looking for these tiny little moons that are circling the big planets, and they're forever finding them. So they all get a proper job. Get a proper job.
I mean, there's more being found for Jupiter as well, but Saturn has just taken over Jupiter again as the
I think Andy's ambition was to name them all on the show.
Yeah. Lou, have you got anything that you want to add about Enceladus?
Well, add one more ocean world to our list.
Yeah.
In fact, NASA has a program called Ocean Worlds for its communication activity with the public. I think, the prevalence of liquid water, as well as the discovery of nitrile and hydrocarbon species in these cryo volcanoes, if you will.
Yeah.
I think it's another tempting story about the possibilities for life under the surface.
Yeah, definitely.
And I'm sure that as we're sending copters to Titan, another ocean world, and we're planning a mission to Europa, another ocean world, I'm sure that Enceladus will be a mission target in the near future.
Absolutely. And one thing that I wasn't able to readily find out was actually how deep those tiger stripes are. Well, we know they go down to the crust, obviously, but I was just wondering, being the old romantic that I am, whether somebody could actually climb down inside the tiger stripes, whether you could actually do that, and how far you would get. But
because the plumes are at their strongest or most energetic is when the actual moon is its furthest away from Jupiter, from Saturn. They said Jupiter then, from Saturn, and apparently they reckon it's this energetic outbursting or outventing of these plumes is due to the fact that while the moon is at its furthest, this is when the gravity of Saturn actually pulls the tiger stripes even further open. So, I mean, the temperature was also recorded by Cassini in the plume of minus 70 degrees C, whereas actually on the surface is 180. So there is quite a bit big temperature difference in
Yeah,
the
minus
in the water
180.
there.
Minus
So.
180.
By the way,
Minus, sorry,
I was gonna say.
minus, yeah.
the minus
It would be
198 centigrade surface temperature is a high noon temperature.
Yeah.
So the temperature on the surface actually can get much lower. And I would expect to kind of answer that question. Europa's orbits closer to Saturn, and it has an icy crust that is overlaying a global ocean. And its icy crust is believed to be some kilometers thick. I would imagine that now we go out to Saturn, we're further away. I would imagine the crust would be even thicker and present even more challenges if one were to try to say melt through it and go swimming in the ocean.
Absolutely. We have a question which you might be able to answer, Lou, from Ian. Could all the rings have been formed by moons dissipating material, moons that have completely dissolved?
Probably not. Probably some of the rings are the result of moons that ventured too close to Saturn. We also have dusty material around Saturn that rings are kind of created by shepherding moons that orbit within the ring plane. So I think it's a variety of phenomena.
Right, and thank you. And Steve says, does the cratered area suggest a more stable ice continent and the striped area a more moving surface?
Well, I think the striped, smoother area indicates that it's been paved over by the material that falls back onto the surface. These fissures and these geysers are seen more in the South Polar region.
Yes.
So you might expect there to be a dominance of smoother surface features in the southern portion of Enceladus.
Yeah. And I suppose all that material falling from the plumes onto the surface, I mean, that would fall like snow, wouldn't it? It must be an amazing thing to be there. It would. I'd love to see that.
At Christmas, yes.
At Christmas. Perfect place for a Christmas vacation. Saturn's moon, Enceladus. Right, so there you are. So that was our moon of the week. We will have another moon of the week next week.
There's one more question in the chat.
Which is...
What is it?
Did Earth have a
ring system after the collision which formed our moon? I think the thinking there is that the moon formed very quickly and that material either escaped or fell back down onto the Earth just as quickly. So yes, for a short period of time, there was a ring of material, but I think that dissipated, at least in a cosmological sense, fairly quickly. Do you all have any other thoughts about that?
No, I think they've discovered, or they think they've discovered in the last few years, that the moon actually formed a lot more rapidly than they'd been thinking before. That it formed in a very short time period, so there probably wouldn't be enough time for rings.
But in the future,
yeah, absolutely, in the future. So
we will have rings.
So there we are. And it's just Daz has been and come back again. Thanks for that, Lou. And thank you also. Lou has also answered the question I asked earlier about the age of the star Fomalhaut. It's about 440 million years. So it is, in fact, a very young star doing its bit with that wonderful planetary disk. Okay, we're going to move on now. And we're going to move on actually to you, Lou, with another edition of your Bad Astronomy series.
Right. There we go. Well, I feel a little bad calling this all bad astronomy. This is really the natural progression of research. You might call it good astronomy gone bad, or something of that nature. But all of the efforts in this case to find out how old the Earth is were based on something. Sometimes it was more based on stories. Sometimes it was based on physical evidence. And so it's all very interesting. I had the most fun putting this together and learning a little bit more about all the efforts put forth to gauge how old the Earth is. So let's get to it.
The name Lord Kelvin springs to mind immediately.
Yes,
Yeah.
yes. He plays a prominent role here.
Yes.
Okay, so we can go back quite a ways. I mean, this has been contemplated for a long time. And the Greek historian Herodotus thought, well, I bet I can estimate the Earth's age by looking at the rate of growth in the Nile Delta.
Really?
Yes, and it's a reasonable,
logical. Yeah.
It's a little hokey, maybe, but it's a very reasonable thinking paradigm. And so as he watched the rate of growth and he kind of backtracked it, almost as we do with the expansion of the universe, backtracking it to its origin, he came out with a number of maybe a few thousand years old. And that's the earliest educated effort or educated guess, I'll call it, that I could find where someone put forth a theory of how old the Earth is and why they are thinking that. So we can jump forward a little bit. There were a lot of people, including James Ussher, who estimated the age of the Earth based on biblical context. And all of this was based on the Old Testament and various stories about genealogy and lineages, as well as time periods between the reigns of kingdoms and the global flooding, which is a part of these stories. And you put all that together, and you're going to get a few thousand years. And it turns out that this estimate posed some problems for other thinkers, other philosophers, other researchers, as they were trying to figure out how old the Earth is, and that the general public actually hung on to this term. And even we know today, we have young Earthers who will stick very strictly to this idea that the Earth is only perhaps about 6,000 years old. But as we will see, that is not the case. John Jolly actually made an estimate of how old the Earth is. Again, the answer is wrong, but the methods, I think, are brilliant. He decided to kind of backtrack how much salt there was in the oceans, assuming that the initial state of the oceans was pure water without any saline. And so he did this, and he made some estimates that said, well, the total salt content of the ocean is maybe 16 times 10 to the 12 tons. And the annual deposit rate, he estimated at 16 times 10 to the 6 tons. So you get about 1 million years out of that. Very interesting, very reasonable science, but incorrect. Isaac Newton tried. He recognized that the heat of an object is proportional to its volume and that the heat that it radiates is proportional to its surface area. So he made an assumption that the Earth is made of iron. In other words, it's homogeneous and it's a single element. And using the Stefan-Boltzmann law, they say it's the kiss of death to put an equation in your slides. And so I apologize to everybody, but I just had to show this. The heat dissipation is a function of E, which is a number between 0 and 1. It just varies depending upon what material you're using, times sigma, which is the Stefan-Boltzmann constant. It's just a number, times temperature to the fourth. And when you play some games with this, you play little algebraic games, you can get a number of about 45,000 years for the age of the Earth. So the Earth is getting a little older as we progress through time here.
But surely, if he thought the Earth is just made of iron, surely if he just dug a hole, he would have seen the rock. So it's obviously not just made of iron.
Well, and where were you when we were making these estimates? We could have used that.
Yeah.
Actually, there were people who I'm forgetting which scientists these were, but they actually had iron balls made for them of different sizes, and they would heat those balls up, and based on the size of the ball and the ratio of surface area to volume and so on, estimate how long it would take for them to cool down. And so and then expand that to the entire Earth, assuming the Earth is one big iron ball. So things like this were done, and it was a reasonable attempt. Now, my favorite, as you were mentioning, is Lord Kelvin. And he said he made a couple of estimates. First, this is the science of the 1800s. Okay, so the spoiler here is that the only physics that we knew at the time was classical physics, and for Lord Kelvin, classical thermodynamics. And so he made some estimates of similar estimates using thermodynamics and a single homogeneous Earth of how quickly the Earth would release its heat. But he also looked at the sun. He made the assumption, and we believe it is a correct assumption, that the sun and the Earth formed about the same time. And so the question is, how does the sun shine? And how long has the sun shone? For example, what if the sun was made of coal and you burned all that coal? How long would the sun last? And it would be only a few thousand years or so. What if the sun is shining due to gravitational contraction? In other words, all this mass pushing in, creating higher temperatures at the core. What could you get out of that? And his estimates were about 20 million years. And then I read a research paper that he wrote, which was it was fascinating, but a little confusing. His conclusion in the paper was that and I have the quote here, that some form of meteoric theory is certainly the true and complete explanation of solar heat, can scarcely be doubted. So this is a theory that the sun shines because of infalling material, infalling planetesimals, transmitting their kinetic energy into heat for the sun. And he made those calculations. And he came out again with a period of about 20 million years. The sun is 20 million years old, so the Earth is probably 20 million years old. And it was based on sound science of the time, but they were missing a few things. I'm going to get to that in a minute. Now, just as there was Lord Kelvin, there was also Charles Darwin. And Darwin, who made his famed 5-year trip on the Beagle, looking at biology, looking at geology around the world, was coming up with different answers. And he felt constrained by the common belief that the Earth was only 6,000 years old. And so it was confusing. Now, he was as much a geologist as a biologist, and he and other geologists and biologists were starting to gather evidence that the Earth was, in fact, much older than this 20 million years that Lord Kelvin came up with. And remember, Kelvin was kind of the Einstein of the 1800s. He was a brilliant physicist.
Yeah.
He was held in very high esteem, even though he was pretty full of himself, frankly. He was. But he was a brilliant scientist. And so when he spoke, people listened. And Darwin was coming up with answers very different than his. And down at the bottom, I quote Darwin as saying, Thomson's view, there's Lord Kelvin, on the recent age of the world have been for some time one of my sorest troubles. They were coming up with completely different answers. Mm-hmm. And so the geologists were coming up with answers based on erosion, based on stratification of layers of the Earth, and the biologists finding evidence of fossils in those stratified layers that indicated that these animals were much older. And then Darwin's development of the theory of evolution, which indicated that evolution takes much more time to form. And it turns out that in his writings on the origin of species, Darwin actually soft-soaped his estimates of 300 or 400 million years, which was his first set of thoughts, because Kelvin said no. Kelvin said no. It's 20 million years. That's as much as you're going to get out of this.
Mm-hmm.
So I thought that was very interesting. And it turns out that at the time there was a little bit of a war going on between that was called the graybeard wars by these old graybeard scientists, the physicists on one end, and the geologists and botanists and biologists on the other end. And it was actually a bit of a slugfest verbally. And they would call each other names and so on and so forth. But it turns out that, as I mentioned, the physicists were wrong, the geologists and biologists were right. And the reason the physicists were wrong is that they didn't have the science they needed.
Yeah.
They didn't have the ability to do radiometric dating until a little bit after the turn of the century, 1900. They didn't know about quantum physics, which is how the sun shines, nuclear fusion, which wasn't, by the way, identified in any detail until about 1934, I think it was. Hans Bethe finally came up with a proton-proton reaction for how the sun shines, how it makes gamma rays in its core. And they did not have matter-energy equivalence, E equals mc squared, which we didn't know about until Einstein published it in 1905. So they did the best they could with the theories that they had. And even though the answers were wrong, I think it was a brilliant set of deductions and calculations and thinking about how to put these things together in order to come up with an educated guess for the age of the Earth, the age of the sun, the age of the solar system. So I just had a blast reading all this, and I hope you did too.
Thank you very much, Lou.
Yeah.
And in fact, of course, a lot of the geological evidence that demonstrated the Earth was a lot older than the physicists thought was done in Scotland by examining rock strata in Scotland. And there was a wonderful series that the BBC did a couple of years ago called Rise of the Continents, which starts with, I can't remember who's, help me out, guys. What's the name of the guy? Is it Ian Stewart? Is that his name?
Yeah, that's the geologist, Scotland.
Yeah, that's right. Yeah, Ian Stewart, Dr. Ian Stewart.
Yeah,
and he did his geological training in Scotland, and he told a fantastic story about how studying the Scottish rocks finally put the idea of an Earth that was only thousands of years old to bed. It's an amazing story. So there we are. Well, that is in fact, an amazing story. Thank you so much for that, Lou.
Mm-hmm.
And
because can I just mention that the last bloke you were talking about was Mr. Darwin. Well, his son wasn't adverse to putting in some astrological theories, and his theory that was proposed in 1879 was fission, which was the formation of the moon. Now, as regards fission, it's not like nuclear fission. It was basically that a rapidly spinning Earth expelled a big mass of its crust out into space, and this actually had some credence all the way up until the Apollo program, and it was proposed that the Pacific Ocean represented the scar of this event. Today, it is known that the oceanic crust that makes up this ocean basin is relatively young. Well, of course, tectonic plates, about 2 million years old or less, whereas the moon is much older. The moon does not consist of oceanic crust, but of mantle material which originated inside the proto-Earth in the Precambrian.
Right.
So so it seemed to be a family thing with making erroneous predictions. But
Well, there are two problems with that, and yes, that was a theory that was considered for quite a while. One, of course, is the composition of the lunar crust, and the other is the angular momentum of the Earth. I think those both posed a few problems for that. But since you bring the moon in, one of the defining observables of all of this was the moon rocks that they brought back and were able to date. Nothing much happens on the moon, and there's no plate tectonics, there's no erosion, and so the rocks on the moon were much older than the oldest rocks they could find here on Earth.
Yeah, absolutely. It's
because I know I had a teacher at school who was still professing that the moon was formed by a big chunk of the Earth crust breaking away,
really?
And that left the Pacific Ocean, and that was back in the 70s.
Right.
So that was even after Apollo. So
it
held on for a while.
Absolutely. All right then. So what's next? Well, some of you asked us for T-shirts, Space Oddities T-shirts that you can proudly wear this summer, and we've obviously listened because it is something we were discussing amongst ourselves anyway. So a few of us have come up with some designs for a Space Oddities T-shirt, and disclaimer: we're not artists, we're not designers. We've done our best, so please don't laugh. So what we would like you to do is to have a look at the designs and see if there's anything that you would even remotely consider wearing on the beach this summer. And if you like a particular design, I've numbered the designs so you can refer to them by number. So in the chat, if you like to put the number of the design that you would like, or if you don't like any of them, which is absolutely fine, because personally I wouldn't blame you, but if you don't like any of them at all, can you just say that in the chat as well? Just say none of them, and we'll go back to the drawing board and try to come up with something better. So without further ado, here are the 5 designs that we thought might be in the running in true Eurovision style to win. Yeah, North. Yeah, well, I'm sure some of them are going to get North. Although I'm not saying which ones, obviously. But anyway, have a look at these and put the number of the design that you like in the comment. And none of them are wearing swimsuits, by the way. So
wow.
Yeah, I know. Sorry about that. So here we are. So the question is, what design would you like to wear on a T-shirt? And number 1 hails from Greater Manchester. No, sorry. So this is the first one, number 1. This is for a black T-shirt, obviously. We find that, with any sort of space images, they look much better on black because of the contrast. So if it's happening in space, it's happening on Space Oddities with our URL at the bottom. So that is number 1.
That's nice.
Number 2, Space Oddities on YouTube. We bring the universe to you, and again with the URL. Very important to have that URL on there so people can find us on YouTube, of course. So that's number 2. Number 3. I think I've made an error with the typing the word Monday there, but anyway, don't worry about that. Every Monday at 8 p.m. UK, 3 p.m. EST, Norma learns amazing things about the universe when she watches the Space Oddities YouTube channel. I know why that's happened. It's because the font hasn't translated over to the software here, but we'll sort the font out. But if you like that idea of a shocked woman at how much she learns about the universe when she watches Space Oddities,
is that Dr. Becky?
Sorry?
Looks like Dr. Becky.
It looks nothing like Dr. Becky. In fact, I'm going to send that to her. She'll be really insulted. I'll tell you.
Nice one, Michael.
I bet you're well with the women, Michael. So there we are. So that's number 3. Number 4. If it's happening in space again, it's happening on Space Oddities, which is sort of our tagline. and that's number 4. And then lastly, there's this one again for a black T-shirt. So there we are, and I'll just run back through those very quickly. So that's number 5. Would you like?
So hang on, Andy. So what happened to my Rod Helen Emu one?
Oh, yeah, we decided for copyright reasons we probably didn't use that one.
Fair enough.
And it was rubbish. So so there you are. Okay, so that's number 5. Number 4. Number 3. Don't worry about the font and the lettering. We can sort that out, but it's just a general idea. Number 2. Space on YouTube, we bring the universe to you, and then back to number 1. So
what's the difference between number 1 and number 5? Are they...
it's just a slightly different design, and number 5 has go through it. The lettering is all different, and it's just different. So there you are. So let's just go back to the first one. So out there in YouTube land, if you like to vote now, and we will have a look at the votes. I can see they're coming in now. Let's actually just put that up on the screen.
It's results of the Swedish jury.
Yeah, results from the Swedish jury, and so there we are. Okay, looks like we have a clear winner of number 1, and that seems to be the most popular one. We'll just let a few more votes come in before we pronounce the design.
And still no emu. Unbelievable.
So
if you want to subvert the contest, you could force a runoff if you vote for something else.
Oh, don't. No, that's probably not a good idea. Thank you, Lou.
Oh, sorry, that's not a good idea. Don't do that.
Okay,
sorry,
we've got one none of the above.
Yeah, Alan's put none of them. Thank you, Alan.
Is that the Grinch on his picture there?
Well, if the Grinch gets in, the emu must follow.
Okay, just give it a. Okay, that seems to be it. Okay, so it looks like number 1 is the winner, and we will therefore proceed with that design for the T-shirts. We will keep you posted of the progress of our T-shirts, and we will proceed to the next stage, which is obviously going to be sourcing a supplier and costing everything, and we will come back to you as soon as we can with news of that, where you can get them and how you're going to get them, and obviously we want to have them ready for the summer, which is it's upon us in Spain, but I'm sure summer may eventually hit the UK, so we'll have them ready for those definitely. Okay. Kenneth suggests something interesting. So number 1 with some of the pics replaced with panel members. We can't quite see all of the comments here because also he wrote except Jonathan. So, so there we go. Will it be washable? Says Derek. Yeah, we'll make sure that it's washable and a good quality stuff, and it's going to last you for some time, because God knows there are enough T-shirt vendors out there selling stuff that's absolutely rubbish. Funnily enough, in my experience, American T-shirts seem to last a hell of a lot longer than ones you can buy in Britain for some peculiar reason. I had a T-shirt from the 1980s or Los Angeles Olympics.
Yeah, I think if you put the panel on there, mine will have to be a flashing one because I'm in and out.
And also, you go flashing a lot.
Yeah.
America's contribution to the world: good T-shirts and Fruit Loops.
Yeah. Ian says, "Is there a design for the back?" We haven't thought about putting a design on the back to keep costs down, to keep the cost of supplying them to you down, but we will look
wear it back to front, really.
Yeah, like you always do, and we will investigate all this. We will see what the difference in cost and how much extra it costs to have front and back designs. Because perhaps we could put the URL on the back and just the design on the front. I don't know. Steve says, make sure there's an XL or bigger for me. Of course we will, Steve. We'll probably do an XXL just for you. But we will...
There's no crop tops then?
Well, do you know, that's funny you should say that. My daughter Chloe said to me today, she thought all the designs were terrible. And she says they're all boomer designs and whatever, and she actually said, "Please, can you do some crop tops?" Because she wants one. So we'll see. Ian is going one better because Ian wants an XXXXL. So that's a tent, isn't it, Ian? Not a T-shirt. So
Marquee.
Yeah. Okay. Well, listen. Don't worry about telling us all your sizes at the moment. We'll deal with that in due course because obviously we need to make sure that we can
Well
get
done,
them.
Steve.
Yeah. Andrew says, a baby grow version. So that'd be good for you, Rachel.
Yep. Little mini Oddie needs one.
Yeah, absolutely. So
The
there
baby,
we are.
that is.
So there we are. Okay, so we'll get back to you as soon as we can, viewers. Thank you so much for taking part in that little poll. I would have done it as a proper YouTube poll, but you can only have 4 options in a YouTube poll, and there were 5 designs. So anyway, thanks so much for taking part. We will get back to you about the T-shirts as soon as we can. And now we come to the big moment of the evening.
NEOWatch then, isn't it?
Round of drums, drum roll, because we are going to give you the results of the Space Oddities May competition to win a telescope. And as you probably know, it was a children's art competition. We've had some fantastic entries from children, and we have found it literally. We genuinely have found it difficult to come up with a winner for this one, but somebody has to win, as they say. So, Rachel, would you like to have the honor of revealing who has won the telescope in our May competition?
I will. We'll take a look at the entries we've had.
Yeah.
And then we'll see who the winner is at the end. So, as Andy said, there's been some really lovely images. So this one was sent in by Charlie Mitchell, who is 6, which is
great.
really cute.
Look at all the detail in Jupiter, yeah.
Yeah, and I love the colours of Jupiter. Really lovely colours as well. That was
really,
great.
really sweet. So well done, Charlie. Really nice. We had one by Lily Mitchell. So I think this is younger sister.
Beautiful. That's great really for 4 years old.
4 years old.
Yeah, 4 years old.
My goodness.
Yeah.
She's great to have such a wide variety of ages joining in.
Yeah.
Then we've got Freddie Stokey, who's 6, and he's done quite a few on here. He's got, obviously, Juice on there. He's got the moons and Jupiter, and there's a picture of him holding it as well, very proudly.
Nice one, Fred.
And I love that he's got Juice saying, "Tell us all about you, Jupiter," which was a really nice touch.
Then we've got one by, sorry, there's just a bigger version in case you can see it. Then
I also like the way his J's are around the wrong way. That's cute. Lovely.
Everyone's a critic.
We've got one by, don't tell his teacher. One by Bella Christie, who's 6, who's gone for sort of a pastel on black situation.
That's lovely. Beautiful.
Very nice.
Lovely colour.
We've got, I can't actually read the name. Is it somebody McLennan? Because the live button is over the top for me. I can't see what the name is.
Hang on. Oh, yes, you're quite right. It's, I think, is it Ronnie? Yeah, Ronnie.
Possibly Ronnie McLennan, yeah, who's age 10. Who's gone for a very different take on it, which is nice.
Yeah.
It's got rings. It's got
rings as well. Yeah, absolutely. Beautiful.
We've got one by Betsy, who's 6. This is showing Jupiter and its moons with Juice nearby. And she has labelled the moons as well. I think you can just see there.
Oh, yes. Very nice. Very nice, Betsy.
Then we've got one by Oliver Tunney, who's age 5, I want to say again. It's underneath there. And he's done some smoke and some smudging, and it was his idea to add on the countdown for the 5, 4, 3, 2, 1.
He's got the launch. That's
which is
unique.
cute.
Oh, sorry.
Charles Darwin entry.
Entry from Darwin. Yeah.
He was banned from the competition, but he did try. We had to tell him he
Not
was not
hard
under
enough,
12.
obviously.
Then we've come on by
Read it a
Olivia
week, Charles.
Johnson, who's 6, who's done, again, Jupiter juice and some nearby stars, it looks like.
Beautiful.
Lovely.
I love how happy they all look as well. They're so proud.
Yeah.
And then one by, again, I can't see the first name, but it's
1 second. 1 second.
that's it, Maisie
Maisie.
Goodridge, who's 8.
Mm.
I really like the colours on this one, actually. I like the
Yeah.
tonal background.
Yeah.
Which is very cool.
Thank you, Maisie. That's wonderful.
And then, again, another sibling off. So we've got Lily Goodridge, 10 years old, who's gone for a similar style.
Kind of a pastel Jupiter.
Yeah. Yeah. Lovely.
Lots of effort making the background black as well.
And you can really get the sort of the spherical shape of Jupiter there, can't you? Rather than just being straight lines, she's actually got
it's got a nice curve to it.
Nice curve to it, yeah. Well done.
Brought her at the equator too, I think, which is accurate.
Yeah. Yeah.
So there's just a closer one up, I think, of Oliver's, in case you couldn't see that. And he tried to write his name as well, bless him. And it's on there.
Very nice.
And so the winner, and because I knew some of the children, I will add that I had no place in the voting. I left it up to the panel to choose, and I didn't find out till everybody had chosen. So it's quite a good surprise. So the winner is Freddie Stokey, age 6.
Well done, Freddie.
Good job, Freddie. And I do know Freddie, and I know that he will be definitely making very good use of the telescope. So I'll be getting him to send us some pictures when it arrives of him using it.
Absolutely.
Oh, excellent. That's lovely.
And what we'd like you to do, Freddie, if you could ask your mummy or daddy to send us an email with your postal address so we know where to send the telescope to, and we'll sort that out for you as soon as we possibly can. And again, a big thank you to our sponsor, Rother Valley Optics, for supplying the telescope. Very generous that they do donate prizes to us to give away in our competitions, which we try to do monthly. We don't always manage it, what with everything else that's going on, but we will be having another competition very soon. But we would also like to say that everyone is a winner, because everybody, all the children whose work you just saw, will receive a consolation prize, a special Space Oddities pack of stuff, which will consist of some space stickers and some magnetic space bookmarks. So all of the children whose work you just saw will receive those. So again, if we could ask the parents of those children whose work we just saw to send us their postal address, we've decided that we're going to send something to everybody. So just pop your postal address in an email, send it to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. And we will get the consolation prizes out to the children as soon as possible, because they are all winners, and there was fantastic work there, and there was some really amazing stuff from children so small, so young, and it's great to see. And we're always saying here on Space Oddities that we do our very best to encourage children into the wonderful world of astronomy, because they are the astronomers of the future, and we depend on them to deliver the science of the next decades. So well done, all you children, and congratulations, Freddie. But as we said, everybody will get a prize. All you have to do is to email us your postal address where you would like it sent to spaceodditieslive@gmail.com, and we will sort that out as soon as we can. Looking forward to the next competition, and I hope, if you're watching, Freddie, that you get many years of wonderful use out of that telescope. And I'm sure you're going to enjoy it. And your lovely teacher, Rachael, who's not as bad as she seems in class. She's actually a nice person, believe it or not. And And I'm sure she will keep us in touch with what you managed to do with your telescope. So all the very best to you, and thank you for entering the competition. Thank everybody for entering the competition. Right. So I think that brings us to the man who about whom it was once said. No, nobody's ever said anything about him actually. So
not printable anyway.
so Jonathan, do you have a NEOWatch for us this month?
I do indeed, Andy. And before everybody switched over to watch Great Expectations, it's a case of leaving the best until last, as per usual. Bump the old figures up.
Is this a new production? Is this a new production of Great Expectations?
It is indeed. Bring the coach and horses around to the front immediately.
You're wasted here, mate. I tell you.
Some of it was filmed in Shrewsbury.
Was it?
Yes, the rest of it in Burnham-on-Sea.
Is that on the BBC?
Don't bother, Andy. Don't bother.
No.
Don't bother.
Now, the Great Expectations was always one of my Dickens favourites. So I might try and find that somewhere then. Okay. Anyway, from Pip to Neos, as it were.
Indeed, yes, and nice to have one of the, I wouldn't say lesser countries, but smaller countries involved with some research. The United Arab Emirates is targeting 7 different space rocks with its ambitious mission to the main asteroid belt. The mission is due to launch in 2028 and visit 7 main belt asteroids, including 6 high-speed flyby encounters en route to rendezvous with asteroid 269 Justatia around April 2034. So that's the United Arab Emirates. They actually announced this plan quite a while back now, but it appears that it's come back into circulation as being a goer rather than just all talk. 269 Justatia measures roughly 33 miles wide, has a reddish hue to it, possibly due to the presence of organic compounds called tholins, which are abundant on Pluto and other icy bodies in the outer solar system.
Mm-hmm.
Now, if the asteroid formed in the outer solar system, this mission could well provide a unique insight into bodies out beyond Neptune. But the overall science objective that the United Arab Emirates have talked about is the understanding of the evolution, the origins and evolution of water-rich asteroids and assessing their potential use for resources. So whereas before we used to look at the asteroids and think, well, that's nice to look at, that we can chart and measure, and it's now being looked at as more of a mining sort of aspect.
Wow.
So that's what they're actually targeting. So that's the mission to launch in 2028, 7 main belt asteroids, but the actual rendezvous itself is with 269 Justatia in around April 2034. From what I can read about it and sort of cross-reference it, like I say, it's not a new project that they've actually. So I don't know whether or not they've received significant funding to make the project a reality. It remains to be seen. But I've also got sort of deep concerns as to whether or not this is actually going to take place. It seems to be something that surfaces from time to time with real it's one of these that sort of just might sort of die a death before it even gets off the ground. But it's nice to see such a project and such an ambitious project as well when you actually fly by the asteroids and then make that. I think they intend to drop a lander on 269 Justatia as well. So very ambitious. In your country, Lou, astronomers have concluded that a rock that smashed through the roof of a residential home in New Jersey's Hopewell Township last Thursday was a rare one. They estimated the age of the rock to be at around about 4.6 billion years old. And that would make it it's a stony chondrite, one of the most primitive rocks. Makes up about 85% of meteorites found on Earth. And most chondrites found to date have been discovered in Antarctica. Only rarely does one crash through populated areas. That said, though, it's a case of the ones that do come down in semi-rural rural areas won't be picked up. But this particular one measured around about 6 inches long, 4 inches wide, weighing about 2.2 pounds, and it slammed into the house. It dented the floorboard, punched 2 holes in the ceiling, and when the actual owners discovered it, it was still warm. So whereas the bulk of these fall not in inhabited areas, it was nice to see this one come down, and it looks a bit of a corker as well, not unlike the Winchcombe meteorite. So that sort of event, not overly rare, but it happened to fall into this particular sort of an area where it was able to be recovered and duly charted. The ESA figures for this week, or the European Space Agency figures, we've got on the list at the moment current total of near-Earth asteroids standing at 31,932. Those that have made it onto the risk list with a slender chance of us being struck by one, 1,483. 121 comets remain on the near-Earth comet list, all being charted and posing no threats whatsoever. And current known asteroids with good orbital information stand at a whopping 1,179,178. So those figures there, 31,932, that's up around about, it's like look, the positional chart movers from last week. That's up about 28 from
Not
last
half.
week. So it's not half baked, dig-a-lig-a-dig dog. So some pretty good charting going on there, and once again, all down to the advancement of the systems that we've got in order to track and trace sort of these, and not like the government. Yeah, 31,932. So a meteor, so a rock falling through somebody's roof, and the United Arab Emirates with grandiose ideas about visiting asteroids. But well done to them for coming up with that. And that's it from your NEOWatch desk.
Thank you very much. Now, it's funny you should mention the meteorite crashing through the roof of the house in New Jersey, Jonathan. We were discussing this this week because the owners did say that when they picked it up, the meteorite was warm to the touch. Which is actually not very likely, to be quite honest, because Lou will now explain to us exactly why meteorites are not warm to the touch when you pick them up.
Cold.
Yeah, I gotta hate when that happens. The meteorite creates a pressure wave in front of it, and there is friction, and the outer portions of it kind of fall away, and so it should be rather cool to the touch when it hits the ground.
Yeah, absolutely. So Daz, if you do discover a meteorite lying on the ground, there seem to be different trains of thought, different ideas about what you should do exactly. I gather you've been looking at this.
Well, yeah. And I was really surprised after all the what we had with the Winchcombe meteorite and all the advertising that got and all the publicity. I'm surprised to find that places like the Natural History Museum and other well-known meteorite sites still recommend that you attack the meteorite with a magnet. Now we all know that that is a no-no.
No,
you stay away from you keep the magnets well away from it, because actually inside the meteorite there is a magnetic record of where that meteorite was actually formed. And if you start attacking it with a meteorite with a magnet, you just wipe all of that information away. So the first thing you'd always do is do not attack it with a meteorite.
No.
Usually the best thing to do is, if you do think you found a meteorite, and they're usually quite, they've got some distinctive marks. They're usually either a brown or a black crusting on the outside. Usually they can be smooth with just some little pitting in them if there's been some outgassing. But if you do find one, the first thing you need to do is take photographs. Take photographs of where it's landing, close-up ones, and then take some of the surrounding area, so with the meteorite still intact. Do not touch it with your hands. And it also, if you can, retrieve it as soon as possible. The longer it's exposed to the atmosphere and to any moisture, the more likely it's going to be contaminated. Now, if you do find a meteorite and you just happen to, or you're out meteorite hunting because there's been a fireball, and they're always, you can always go on sites and find out when there's been a big fireball come down, so there's a chance that there could be meteorites around. Is what you need is you either need a very clean pair of gloves or a pair of metal tongs, or if you haven't got those, some foil. And what you do is you actually pick up the meteorite when you want to move it, once you've taken the photographs. And when you take the photographs, if you can put something like a coin or something that's got a recognized dimension as a scale so people know what it actually looks like, you'll take the photographs with that. So it just gives some the idea of scale. When you remove the meteorite, when you pick it up, if you can, put it in something like a Ziploc type bag, and then put it inside a lunchbox or a Tupperware box. If you haven't got a Ziploc bag, just put it in the Tupperware box, but then seal it with sellotape or cling film. The reason for that also is because probably there could be trapped inside gases, which will leach out. And if you've got it in a sealed box, when they open it, when you go take it to have it analysed and all that, they can actually analyse these gases, and that will give them extra information. So it's basically, do not touch it, do not attack it with a magnet, and get it into a sealed container as soon as possible, and then notify the authorities. And there's several places you can go to. But why would you want to basically collect meteorites? Well, just in here alone, in the UK alone, it says about 69,000 meteorites have been found worldwide. Only 40 of these 69,000 were photographed as they arrived as a fireball, including of course, the Winchcombe, which I mentioned earlier, which fell to Earth on the 28th of February 2021. So that was actually during the COVID times. Meteor camera networks photograph incoming meteorites from multiple UK Now, if you want to see some of these images, it's best. One of the best sites to go to is UKMON. MON, yeah, I'm sure that's what it's called, wasn't it?
Yeah, it is.
UK. And you can... Yeah, and you can actually see these images on there. And Mary, who's usually a panelist on here, her and her husband have got several meteorite cameras set up, and they're always displaying their meteorite showers that they're using. And what all these locations, because there's hundreds all throughout the country, using all the cameras, they can also plot which way it was going and possibly where it would actually fall. And basically, as we said, looking at these, once you get these in the laboratory, once you start looking at these, they can tell us about the early solar system, or if they were formed outside the solar system as well. There's several different types, and I think the Winchcombe was a carbonaceous chondrite.
Yeah.
If I remember rightly, which was a rare one. But if you do find one, as I said, I won't go into too much more detail, but get in touch with the authorities. Meteorites belong to the person who owns the land. If it falls on your land, you can keep it if you wish, but the best thing to do is get it to the National Natural History Museum, where they can study it and find out more about the early solar system, how the solar system formed, and basically what's going on out there. Because some of these also contain possible like amino acids and things like that, which are quite like I say, popular, not popular. There's a lot of them present in these chondrites, and of course they come forward to actually form some life. So that's basically it.
That's no fun. The first thing, you take the picture, the first thing you do is you put it up on social media. The second thing you do is you call everyone you know, tell them about a meteorite. The third thing you do is you get it up on eBay. I mean, let's be rational.
Yeah.
I think as well,
Well,
Dad. I think the UK Mon, they're always after people getting involved and putting up their own cameras as well. So
Yeah,
if there's
yeah,
anything that you're
yeah.
interested in, it's
They can
well
offer
worth
you
getting
all
involved
the
with.
all the advice, all the information that you need, and that's all. That's all you've got to search for is UK Mon on your search engine, and then it'll come up. And there's loads of information in there.
I'll put them.
And as Jonathan says, they're always looking for more people to put up more cameras. And as regards what Lou was just saying, as regards the Winchcombe meteorite, that was actually removed and was given to the Natural History Museum for studying. But even the dent that it put on the driveway was cut out, and that is now got pride of place next to the meteorite in the museum. They had to have their drive resurfaced. So, but they've actually made quite a little bit of business about it because now they do tours.
Yeah,
They do meteorite tours. So,
I'll put a link to the UK Mon site in the YouTube chat.
yes.
excellent.
I'll put it in the description of the video, definitely.
Yeah.
So we'll include a link there after the program. Right, so all very interesting stuff. Whatever you do, don't follow the examples of the two professional meteor hunters in the wonderful TV series Meteorite Men, because the first thing they do is slap a magnet against a possible find. You have to remember they're doing it on a commercial basis, and they do it to make money. So they're not that bothered about spoiling the meteorites too much. But if you haven't seen Meteorite Men, I'm not sure where it's available. I'm sure there are some bits on YouTube, but it's a really entertaining series. Two guys traveling the world searching for meteorites that they can then sell. So there we are, and I think that just about brings us to the end of today. One thing we need to say was to go over to Michael. Michael wanted to say something.
Yes, I do. I just want to put my slide up if I can. Oops.
1 second.
No, that didn't work.
Oh, okay. I can't see it there, Michael.
Should be there.
Yeah, got it now.
Yeah.
There we are.
Yeah, I just want to invite everybody to a talk this Thursday, rather, by spaceflight author Ben Evans. Thursday, the 18th of May at 8 o'clock UK time. The talk is entitled "The Right Man: Remembering Gordon Cooper's Leap of Faith." Gordon Cooper flew the last Mercury capsule. Gordon was one of the first 7 astronauts that NASA recruited in the early 60s to fly the Mercury mission, and they were the real right stuff of astronauts at that time. This is all about the flight and the man himself, and this is at 8 o'clock on Thursday by Ben Evans. And if you want to go to join us there, if you look at gospacewatch.earth and follow the links to the lecture. So everybody welcome.
Thank you, Michael. There's something to look out for, certainly. Also, just before we go, this Sunday sees the launch of the Axiom 2 mission. This is the second in the sequence of launches to the International Space Station by the company Axiom. So it's a private mission flying on a SpaceX Falcon. And we're going to cover it live here on YouTube on Sunday evening. What was it, 10:35 UK time, guys?
About 10:30ish.
About
yeah,
10:30 UK time.
UK
we
time.
will be here to cover the launch of Axiom 2 to the International Space Station. It'd be great if you could join us. And having said that, I'd like to say thank you to the panel tonight. Thank you, guys.
Thank you, panel.
Wonderful stuff tonight. We will, of course, return the same time next week, 8 p.m. UK or 3 p.m. EST, live on YouTube, live on Facebook. And congratulations again to Freddie for winning the telescope. And
well done, Freddie. Well done, Freddie.
And thank you to every child who entered the competition. And you will, of course, as I said, if you send us your postal address, then we will send you your consolation prizes in the post as soon as we possibly can,
Crackerjack pencil and pen.
Oh gosh, yeah.
Turn your eyes now, Jonathan.
Well, thank you, Peter Grave, and we will be back, of course, with another lot of stuff next week. And we'd like to wish you all a fantastic week. Take care of yourselves. So, from all of us here at Space Oddities, say goodbye, panel.
Goodbye.
Bye.
Bye, panel.
Hope you've enjoyed yourselves tonight, viewers, and thank you for being here. And thank you for your feelings about the T-shirts. We'll sort that out as soon as we can. Okay, then. So thank you from everybody at Space Oddities. Thank you to all the Valley Optics again. And until Sunday, if you're around at 10:30 in the evening, we'll be live here on YouTube and Facebook again. But if not, we'll see you next Monday. So take care, everybody, and goodbye.